Welcome to the SSI Orbit podcast, a forum where we explore the ever-growing ecosystems of self-sovereign identity. And I'm your host, Mathieu Glaude. Today I talk with Ingo Rübe, founder and CEO of Kilt Protocol. Now, Kilt is a blockchain protocol for issuing self-sovereign anonymous verifiable credentials. Kilt is part of the Kusama network and also the Polkadot ecosystem. And for those who don't know Polkadot's a permissionless blockchain with a token economy of its own. A comparable for non-crypto folks would be something like Ethereum. So in this conversation, we discuss why is the common saying data is the new oil false? We talk about alternative forms of identification on the web and the social KYC product Ingo and team are bringing to market. We talk about use cases of SSI in gaming and how gaming is poised to become an early adopter of SSI. We talk about generally identity in the Web3 realm. And then we get into the Kilt protocol, which uses the permissionless blockchain as a trust anchor. We discuss DIDs and verifiable credentials in crypto, and we talk about use cases for verifiable credentials such as ratings and reputations in the DeFi space. Now, without further ado, here's my conversation with Ingo Rübe. Enjoy. After our last conversation, you kind of got me thinking a little more about why, and we've been quite involved in the digital identity space for the past year and a half, and there's a big movement of digitizing government-issued IDs or documents. It's the classic OCRing a driver's license or a passport and doing liveness testing, and basically just digitizing that for processes that need to happen over the internet and not in person anymore. So you got me thinking a little more about just why we still use that. Like, we understand why it's used in the real world in the paper-based interactions, but this as more and more things kind of move towards online, the first actions that we always tend to take is we try to just replicate exactly what happens in the physical world to the online world. I love the story of the. I think there's still companies that do this for some reason, but in the internet, in the late 90s, like, everyone was trying to do stuff like do fax on the internet or do certain things that it's just like, without realizing there's maybe better ways of doing the same type of thing that you're trying to achieve using these different mechanisms that are possible with this new paradigm that was called the internet. And I feel like we repeat the same thing over and over again. And now there's a lot, because there's more and more transactions that happen online, more and more financial institutions are conducting transactions online. They're using these digitized government IDs to be able to do their KYC processes or to do their AML processes, which they have to do because they're operating under the laws of specific legal jurisdictions, which means that they have to do that. I think we're moving more and more towards digitally native processes overall, where and especially in the Web3 space where we both come from, where you could literally do everything digitally native without having to go to an outside payment rail or having to go to an outside institution. Everything could be done, including work with the gig economy and a lot of work happening just online today. Like, if I'm a software developer, it's stuff that happens online. There's stuff that could be tracked online. We could use smart contracts for processes online. We could use crypto or whatever type of digital assets to automate payments and transactions online. So when things are digitally native like that, there definitely are some use cases that don't necessarily require a government ID, and that's what I kind of want to get into today. But so with that intro, and I think people always try to compare apples to apples. So doing fax online or getting government issued IDs online, there's a common saying that, again, in this apples to apples comparison, that data is the new oil. What is wrong about this statement in your point of view?
Oh, I think it's completely wrong. And I think this statement is it's probably more than 10 years old. And I think there were not many statements out there in the world which caused greater damage. Because when you go to a normal manager in a traditional company and you tell them data is the new oil, then they believe that. And then they look at what would I do with oil. Well, first I need to drill for oil, and then I'll need to accumulate oil. And when I have a lot of oil, then I be the sheikh, and I have a lot, and I'm extremely rich. And this is what the managers want for their companies. But then they didn't look at that data actually behaves completely different from oil. Because first of all, if I have some oil and I use it, for example, to heat my apartment, then it's gone. And when I have data and I use it, then it's still there. So that's quite a difference from oil. The second thing about where they differ, I think, is if I share my oil with you, so I have a gallon and I want to share it with you, so I have half a gallon and I have half a gallon, then I have less than I had before and you have more. But when I share data, like information with you, then you have it and I have it. And then we actually then it's not halved, it's doubled, right? So that's quite interesting things. And then also, if I have some oil, and I think this is the most important one, which most of the managers don't understand. If I have some oil, I can still heat my apartment with it. If I have some data, I can't do anything with it. And there's a study, I don't remember really where it came from, but I think it's also common sense that 80% of the companies who started accumulating, especially user data, never found a business model how they can monetize them. So they're collecting lots of data, which produces lots of risk to them, because having a lot of data also means that somebody could break in and steal the data or manipulate the data, and then you can get sued for it. So you're actually producing a lot of risk and you're using a lot of power for producing the data and collecting the data, and the outcome of it is absolutely zero. And the reason for that is actually that the people didn't understand that for utilizing data, you need a huge amount of data. And thinking and to understand what a huge amount of data is, just think of a huge amount of data and then multiply it with 2 billion. This is the amount of data that you need before you can utilize it. There was a report or a scientific paper actually given out by Google, I think, in 2006. The name is The Unreasonable Effectiveness of Data, where they actually point out very well in scenarios for machine learning that if you want more accuracy in machine learning, so let's say we have an algorithm and it can see the difference between apples and bananas. If you feed this with 1 million pictures of an apple and 1 million pictures of bananas, then it will be accurate maybe 93% of the times when you feed it a new picture. If you want to get this 93% to 94%, you have to not do 1 million pictures of bananas and apples, but you have to use 10 million pictures of apples and bananas. So it is only working and it is only useful when you really have huge amounts of data. And when there comes some manager, I was working in the media industry quite a long time, and you found a lot of managers there who said, hey, let's collect the consumer data of 2 million users we have. And then the only thing that you can say, okay, can we maybe go up to 2 billion users? Because otherwise it really doesn't make sense. And then they say, well, we don't have 2 billion users. We only have 2 million users. And then you can stop the whole thing from the beginning. You don't have to look for the oil, because the amount of oil that you get is so little that you really literally only produce risk, but no positive things. And so I think it's really dangerous. We're wasting a lot of time, wasting a lot of money in collecting data from at media companies, name them everything, whatnot, actually, where it's actually, we don't have chances to collect data. Look at Google, what they're doing. They're giving us Gmail. Gmail is really, really nice. And it doesn't really do advertising in there, right? So you can use Gmail for free. The whole world is using Gmail. Why is it profitable for them? It's profitable for them because they get all the emails we write, and from not reading email one by one, but having algorithms scan through the emails, they can find out what's trending, they can find out what people talk about generally, they can see which countries speak with which other countries and all that, and make statistics on that and have the machine learning algorithms train on that. Also the translation algorithms and stuff like that. So they're using the data, and using this data is so valuable for them because it's such a big amount of data, because we're doing so many emails on Gmail that it starts accounting for them. If I now have the same idea as a small company and say, hey, I make a Ingo mail, that won't work because I don't get the usership.
I do like your point of diminishing return and risks are higher. It kind of seems like every additional % of efficacy on whatever algorithm you want to write requires some exponential number of more data to hit that. And it does seem like just a lot of the models on the internet today is kind of like collect and then figure out what to do with it. It's not like there's no trust building or progressive profile building and collecting as you need for whatever you're doing. It's really give me everything up front, and then I'll figure out what to do with it after. At the same time with Gmail, like the other thing is like we still use Gmail because it's awesome. We still use Google Maps because it's awesome.
Yeah, well, I made a short survey in just with people I know, and they're all using this Google Maps thing, and also the Apple thing is also great, which says, okay, when you drive into this street, there's a congestion, it says a red line, and I said, how do they know? And nobody ever said, yeah, well, they're tracking me right now and see if I move fast or if I move slow. If I move slow, then it's obviously congestion. And if I move fast, then there's no congestion. People don't know that. Well, they clicked on the box which says we were using your data, but people obviously they think they have a camera looking at the street or something inside the street, which monitors how many cars fly over it or whatever. So it's just the user data is used for that, and well, it's a trade-off, of course. Mr. Apple and Mr. Google obviously know where you are, but as a trade, but then you get the information where to drive and where not, and it's up to you if you want to be part of the game or not.
There's another significant difference there in the data oil comparison is with the data privacy laws getting stricter and stricter. Organizations are being told that the data you have is actually not your data, that it's owned by your customers or your consumers, and they have the right to take it or the right to have it erased or deleted. Whereas I think it's a good thing. Well, from an economic standpoint, it's a good thing having a lot of barrels of oil, and you don't have anyone coming and telling you that this is not your oil. So it's I guess there are liabilities with holding oil because you don't want anything to catch on fire or anything, but it's a little bit of a different liability when it comes to data. So you've been working on a product called Social KYC now. So this kind of falls in line with my statement at the start. So we have these, like, as there's more and more digitally first interactions, we start thinking about potentially alternative ways of identifying or authenticating someone. And social KYC seems like one of these alternate mechanisms to the traditional ones. What is social KYC?
In a nutshell, everyone knows KYC. It's about getting your passport, taking your passport, and somehow going to some organization which is trusted. If you want a new bank account, you use KYC. You go to the bank or to another organization, and you take your passport, and they check if you are really who you pretend to be, and then you get this certified ones, and then you can open your bank account. And unfortunately, then it's gone. And if you want to go to the next bank, then you have to do it again. I don't doubt this. I think it is necessary, especially when you have regulations and rules around you, that KYC is absolutely valuable. We can make it obviously a little bit better. So reusable KYC would be something that would really be in favor of most people, especially if they do some crypto accounts from time to time, and that's really annoying to do it all over again all the time. But then there's use cases where the government identity doesn't really makes sense or isn't so useful. So take the example, I want to play a massive multiplayer online game, and I want to compete with someone, but I don't want to compete with just anyone, but because I'm just a great player, I want to compete with other great players, and I found a great player in China, and I want to compete with this guy. And I really want to know if this guy who pretends there in the internet, he's a great player, is the great player or not. It wouldn't help me if I know his street address. It wouldn't help me if I have his name, his real name, or see his passport, actually. What I'm interested in is how his history in the internet actually is. So it would be more interesting for me if he could send me a credential which says I won these three tournaments. It would be interesting for me to see a credential which says I actually own this Discord account, because then I know this is this guy on Discord. It would also be interesting for me to know that he actually controls this and this Twitter handle, because if it turns out that he's a liar and he doesn't play fair, or so, I might want to be able to use his Twitter account as a hashtag and say, hey, be careful when you play with this guy, this is dangerous. This is much more likely than if he cheats me on the game, that I go to the Chinese government and say, can you please prosecute somehow this guy because he's cheating a game, and probably won't be successful. So I have much more power when I know his internet credentials. And to make a simple point, government credentials are useful in some use cases, and internet credentials are useful in some other cases. And they may be even overlapping here and there. And this is why we designed social KYC, which is a pretty simple service where you can just go to. It's going to be a website. It's not online yet. It's going to be online maybe in August. You just go there and you prove to the service that you own that you own the control over certain social media accounts, or your email address, or your phone number. How does it work? Actually pretty simple. You go there, you say, this is my email address. You type in your email address, and it says, okay, we send an email to this address with a link, please click the link. And then you have proven that you can at least receive email for this email address. And then we issue a credential to you, which is then stored at your site, which says this guy who owns this actually is in the control of this email address. And then you can take this credential and move it over to, for example, a service which wants to know about that, and then you can prove that you are actually owning this or controlling this email address. And this can be done not only for emails, but can also be done for phone numbers, for Twitter accounts, for WeChat accounts, for whatever you would like. And the service which you want to use, or a person you want to identify against, can actually tell you, okay, I need at least 3 internet credentials. And the more you have, the surer you can actually make that you're talking to the right person. Because if I tell you in a proved way, if I can prove to you that this is my email address, this is my phone number, and this is my Twitter handle, it's highly unlikely that somebody hacked all 3 of them, right? And so you can be absolutely sure that you're talking to me, and then you're not talking to a dog in the internet anymore, or to a potential dog, or to a potential bot, but then you talk to actually a person which has this history.
Building confidence on someone doesn't necessarily come from one reliable source. The more reliable sources that give you inputs that you could start stacking them on each other increases a level of assurance that you would have on someone. So I could definitely see 2 sides to this. One, that you could actually use this to supplement existing legal KYC processes that just gives you additional layers to increase your assurance. But then you also have the use cases where you just don't need those IDs at all, because it doesn't matter. There's no regulations that requires that. There's no reason to share your government issued data attributes with anyone. And the gaming one it's quite interesting, because in line with, I guess there's a lot of gamers that are in crypto. There's a lot of decentralized game platforms that are popping up as well. It seems like people that are in the gaming industry are just more digitally savvy already to adopt something like this. It's also interesting because it's more of a bottom-up approach, right? Where there's a need with the gamers that they need to have more confidence in what they're doing, or knowing who they're interacting with or who to interact with is helpful for the progression and what they're trying to do. So it's really, would you say it's more of in line with crypto and Web3, like the social KYC is more of a bottom-up type of thing approach that you're taking?
I think it's very much connected to Web3, because it's one thing that I didn't mention, but which is extremely important, is that social KYC doesn't store your data. So it relies on the principle of decentralized identifiers and verifiable credentials. And it utilizes the Kill blockchain for storing the validity of those credentials. So maybe it's good if I explain just a minute why we need those decentralized identifiers. I think because you were talking in the beginning about a digital identity and sending around facts. So when you look at what identity actually is, it consists of two things, and one of them is an identifier. And in the real world, now outside the internet, this identifier is actually not issued by a state or a government or a company or something like that. It is issued by the person itself. So an identifier for me would be my fingerprint, it would be my face, and also my name. Names given by the parents, but I can change it probably. So, this is something which is self-issued. So this is like really, really decentralized. Doesn't get any more decentralized, right? And this is what we use in the real world. So the real world isn't always the worst thing to look at. And but this is not my identity. This is just my face or my thumb or my name. So it just identifies me, but it's not my identity. So my identity actually grows when I add credentials to that. So I'm a European, so I have a European passport, and I have a driver's license, and I have a university degree, and I have a key card which opens the door to this office. So I can obviously enter this office. So this all builds my identity, and all those things are somehow connected to my identifier. So if I have this totally decentralized identifier, and then I connect it to verifiable credentials, which are issued by trusted entities. And those things together actually form my identity. And in the internet, we first took one step back. We said, let's have companies like Google and Facebook and all those actually hold our digital identity. They control the identifiers. They give us the identifier. They give us the credentials. They store credentials for us. They send credentials to other services for us. This takes away a lot of freedom that we already had in the physical world, and it makes it worse than it was in the physical world in the internet. And this is what we have to stop, and where we have to be really, really cautious about. So the first thing that we have to do if we want to liberate ourselves and liberate our data from some big multinational companies is that we have to get control of the identifiers again. And that means that we need an identifier which we can produce on our own computer, which is decentralized identifier. So this is what's called DID. What you do is just like when you have a crypto wallet, you download a piece of software, you start the piece of software, and it generates your decentralized identifier on your computer. And this consists, as in crypto, of a signing key and of an encryption key, encryption and decryption key. And that means that you have your private key, you can sign your messages with it, certainly that you can be made absolutely sure that you signed it, but you also have the public key part of it, which you can share with others and say, okay, now this is me, this is my identifier. So then you have an identifier already. And then later you can use verifiable credentials from others, which come from a gaming company, which comes from someone who makes a gaming tournament and issues credentials about who won it and stuff like that. But those are then linked to those decentralized identifiers again, so that I can be absolutely sure if I got this thing, that I got it off a reliable source, and that it actually belongs to me. And only if I want to use it, it is going to be used. And this is exactly what we do in the physical world again. So I have my personal signature. If I sign something, then I do this deliberately, right? It's not somebody else signing things for me. So this is my identifier again. So, and this is how we use the DIDs, the decentralized identifiers. Again, I have those credentials on my computer and I sign them with my DID, and then I can send them away to some service, and then the service knows, okay, this is actually the person who sent it. And this is how the use case works with the social KYC. So if I say, this is my nice, I won the tournament in Tokyo thing, and I want to prove to someone else that I really am this person, then I just send him the verifiable credential about winning this, and he will see, okay, it's signed by this person, and it's also signed by this entity, which I also trust, the Tokyo tournament, don't know, thingy. And then I can also send him this email address thing generated by social KYC, which is also signed by the same identifier and signed by another trusted entity, which is the social KYC company. And I trust them both, so I can actually know this identity is now taking part in this game, and I know exactly that it is this identity and not someone else. So this makes it really, really valuable. And as you said, in the gaming industry is definitely one of the first adopter of this, because they are, as you say, technology savvy, but they're also a lot of very agile young people where you don't run against walls when you try to bring in something which is completely new, like, hey, let's have decentralized identifiers, which we had for 10,000 years now, but in the internet it's new, and it's more complicated when you talk to a media company, so definitely not too bad.
When you were talking about this use case of having a verifiable credential that shows you that you won a certain gaming event in Tokyo, for example, we start talking about, like, I need to be able to trust, if I'm a verifier, I need to be able to trust the issuer of this credential, or in your model you refer to as the attesters. So when someone is showing me a proof request, I need to be able to verify the provenance of this claim, and I need to be able to trust it. So in this Tokyo tournament use case, I trust the issuer of this claim because it's a reputable kind of event organizer in the industry, and I trust them. Are those most of the use cases where it's just there is some already a reputation that's not coded anywhere? Like, I'm not relying on code for a reputation, but I'm just relying on, oh yeah, this is a trusted organization. Are most of the use cases like that, like in the gaming space?
I think, yeah, we made a lot of research actually on how does reputation and how does trust evolve, and how can it be coded. And we were looking at many different projects which tried to say, especially around 2017, 2018 in the ICO times, there were so many blockchain companies which were solving this problem with great reputation and scoring thingies, and they're all gone, and that has a good reason. I don't think it will work. This is because of how humans are structured. Trust is something that we inherently have. It starts probably with the parents, and then it goes on with education. Some people trust some kind of church, some people trust some kind of organizations, some kind of people trust some kind of government, and you definitely have, and then you have a job, and then you somehow have to trust your boss and stuff like that. So we are structured in this way, and I think it's maybe it's not genetic, but it's so much learned that we won't get this out of of our bodies and just say, now I'm trusting an algorithm. I think the trust market, I would say, is extremely big Just some examples. So if you found a newspaper, for example, how will you get your trust? The only thing getting trust, only possibility is actually do good job, right? So if you start printing your newspaper and then some readers maybe occasionally read it and find out, okay, this is trustworthy, this is entertaining, and this is not too expensive, and then they will start trusting your newspaper and buying it eventually, and then you have a business model on top of that. But it evolves over time, and this is what always has to happen somehow. And so I think the only way to build trust is actually to do a good job over time. Even if you say that governments have somehow automatic trust, no, they have automatic trust only for a certain time. When you live in a democracy, you can change your government from time to time. Even if you don't live in a democracy, then you probably, after maybe a longer time, there will be a revolution, and because people don't trust the government anymore. And I think all those trust score thingies that have been built, they were pretty thought out and very smart oftentimes. But they can be spoofed so easily. Even if you take complicated models like the more trust I have, the more trust I can give to others, then it immediately business models pop out like, okay, I give you some of my trust, but you have to invite me for dinner and stuff like that. So it's and then the person is not trusted anymore, and I lose maybe some of my trust because I give it away, but but I'm having so much that I can actually afford to do it in the wrong way. I think it's just not going to work. We have to use the real world for generating trust. It's not happening on a blockchain. Unfortunately, I would have loved to see something like that, but looking at many projects and also doing research in the field, we found out probably never.
So in another use case, one that interests me quite a bit, and we're seeing some traction in the verifiable credential space, is just the proof of education or proof of skills type of thing, right? And it's again back to the idea of there's more and more stuff that's going digitally native. Like you could start really considering using micro credentials or micro skills if you complete a project, or you deploy certain code, or you don't need to wait 3 years to get a degree. You could start really inching away and getting proofs for what you're doing. But I guess in that use case too, that what you're saying is that whoever is issuing these credentials to me as I'm upping my skills, whether it's on a job or in a game, this issuer needs to have some sort of real world reputation for these credentials that I'm presenting to whoever to be accepted.
Exactly. What works is delegation trees or trees of trust. That is something that is so when we take this education example, that's a good one. So for example, you could have a university which would issue you your university degree, which is the big one, and the university is then probably trusted by government or whatever, or it just has a great name for itself, so it issues credentials. But this university could also issue credentials to small laboratories, or to even to individuals, or to people who visited the university before or so, which they trust and say that they normally do a good job. And then those people could issue to the students some certain credentials, and then those credentials could be collected and brought to the university and say, now we exchange all those 25 credentials to this one credential because they are all signed by people that you actually trusted. And then those credentials which the students get, which are from scholars or so, they could even be handed in with other universities if the other university trusts the tree of trust from the first university, because then the scholar has a stamp, and so to say, a digital stamp, saying I'm a trusted scholar from University X, and I'm issuing to student Y now this credential, and then student Y goes to University Z and says, I got this, and they can say, okay, I believe this tree of trust, so this can be part of your university degree that you get from my university. So those things are possible, and this is exactly what we have implemented in the Guild protocol, my main project.
As an organization, I'm part of the Northern Bloc, we're quite implicated in the Trust over IP Foundation, which is building, help building frameworks to build governance models for trust ecosystems. Trust registries is a concept that's gaining a lot more popularity too. But again, you need to have real world involvement that is creating these trust registries. But the reason I'm bringing Trust over IP up is additionally within this organization, I am a co-chair of the Utility Foundry Working Group. And the Utility Foundry Working Group, our purpose is really the base layer or the base foundation for any trusted ecosystem of DIDs or verifiable credentials to really thrive. You need to have this root of trust on the bottom. There's a lot of focus on Hyperledger stuff today, and that's why I'm bringing it up, because the last time I checked, and there might be more right now, there's close to 100 DID methods that are checked into W3C library, and Kilt is one of them, I do believe. And so for our audience, would you mind just talking a little bit about Kilt? Like, what is Kilt, and how have you evolved over the past few years to create Kilt, and what's happening with Kilt outside of just the social KYC stuff we spoke about?
Yeah, sure. Kilt was born like more than 3 years ago with the idea that verifiable credentials and decentralized identifiers are something that will definitely be utilized by not only by people, but also very much by industry, because it's not only about the identity of a person, it's mostly about the identity of a service or of a thing. It's like Internet of Things, because also a thing or a service can have certain properties, can have certain rights, certain duties, which can represent and be represented by verifiable credentials. So, for example, I'm a piece of machinery and I'm compliant to ISO or whatever, and this is an interesting information when I want to work with another thing, so I can send my credentials over there, and then I can say, yeah, we can cooperate and stuff like that. So we see that there's a huge need for that. And we also saw that there are some companies out there who do digital identity, especially in the blockchain scene. And that wasn't so successful for most of them. And we looked at it, and most of them were actually on Ethereum. And then we tried to find out why doesn't it work. And then we have quite good industry ties, and then we talked to industry, why doesn't it work? And then they said, yeah, basically it's the gas cost, because you cannot, when you do production in an industrial environment, then you need to know what your production costs are. And if this involves the usage of a smart contract where you don't know how much the cost for running this contract is going to be, then you can't use it. And then we looked at others, which basically were doing a lot on Hyperledger Indy, because Hyperledger Indy is exactly solving this problem, right? Because you can run it as a permission blockchain, and then you can predict the cost. How crazy. Then we asked them, okay, then why aren't you using this one that's there? And then they say, yeah, actually we don't want to use this one because it makes us dependent on the people who run the blockchain, and we don't want to be dependent on that. Because, and it's don't get me wrong, you're not storing the credentials on the blockchain. That would be terrible, because they might contain personal data, and you don't want that on the blockchain, and they're too big anyway. You store the credential with the user or the machine or the thing, but what you store on the blockchain normally is the validity of the credential. So the attester or issuer saying, I issued this and it is now valid. And if I find out that the production methods of this thing are changed, and then I can not prove, I can actually not attest anymore that this is, I don't know, fair trade coffee, because now they're buying somewhere else, then I have to revoke this credential. I must be able to revoke this credential without asking the guy who possesses it right now. It's a bit like getting rid of your driver's license because you drove too fast or too drunk or so. Then somebody must be able to revoke your driver's license. And this is really complicated when you have only a digital driver's license, because it's just numbers, and no one can take away numbers from you, just can replicate them. They're just data, right? And so I need somehow an entity, a thingy, which which controls the validity of those credentials. And if this validity of the credentials is controlled by a company again, then this company is the most dangerous company in the whole world, because it could actually revoke all the credentials, and then nothing works anymore. So we want this actually really on a permissionless blockchain, because then it is controlled by community and it cannot be attacked by anyone. So it's absolute mathematical proof that if something is revoked or not revoked. So this is where we need a permissionless blockchain. Unfortunately, we also need the fact that we need to know how much it will cost to write a credential or to write a hash of a credential on the blockchain. And so this is a dilemma. And so one leads you to Ethereum and one leads you to Hyperledger, and actually both have significant disadvantages. And we thought, okay, maybe we can somehow solve both at the same time, so solve the dilemma. And this was the time when Polkadot basically came up, and Polkadot solves exactly that, right? By being a parachain to the Polkadot network, we can control the gas prices, but we can have still the proof, the security of a permissionless network, because all our blocks that we produce are audited by the Polkadot relay chain, which has a huge decentralized power behind it. And so we can do both at the same thing. So this was the reason why we said, okay, let's do digital identity on top of Polkadot. And this is what we started in 2018 or late 2018. And what does KILT do? It basically does all the things which are specified in the standards, decentralized identity, decentralized identifiers, and verifiable credentials. And it does a little bit on top of that. So it has those delegation trees, because delegation trees happen in the real world, right? It's not actually the civil servant or whoever giving me the driver's license, which takes the responsibility for it. It is some organization behind him, like the driver's license department or even the Ministry for Transportation or so. So we need to have those trees in there, and they have complicated revocation mechanisms and stuff like that. And 2 or 3, 4 other things like partial disclosure, selective disclosure of credentials, which we added on top of the standard to make it more usable for industry. This is basically what KILT does, and it's a blockchain. It's a level 1 blockchain, not on Ethereum. It's level 1, has its own token economy and all that. Is running on a network of computers, which are completely decentralized, of course, and is connected to the relay chain, or will be connected to the relay chain of Kusama.
There's always something interesting about the permissionless blockchains, where just the fact that you don't need to run a node, if there's enough of an incentive mechanism through the tokens built into the blockchain, you could have a little more confidence about the viability or for long-term operation of the blockchain. You could always fork it if you wanted to at a certain point, but you're not necessarily relying on getting a bunch of corporates around the table and instructing them to run a node, and they bear the costs of this, and it's not cheap either to do that. So
it's risky, because you really don't control this consortium, right? And if we say we want to have something which is controlled 100% by us, then actually we need also a network which is not controlled by a bunch of companies, and because it can become dangerous. And it's much better to, so that's actually the idea behind blockchain, right? It delivers the mathematical truth instead of trust. And then if you build a permission blockchain, you have to trust the people who run the blockchain again. So actually that's not even a blockchain in the original sense, right? In the original sense, it would be a distributed database, which can also produce blocks and stuff like that. But the original idea of the Bitcoin and Ethereum makers was actually that we built something where you don't have to trust, where you can live in a trustless environment. And then if you go to permission blockchains, trust is absolutely necessary again.
Yeah, with some caveats probably for every single one of these ecosystems or blockchain has the caveats on how decentralized they are and other stuff, which that's for another conversation. But so did you build, or are you and your team, do you have a wallet that's a solution in production? There seems to be a lot of benefits of having crypto wallets that are actually tied to verifiable credentials and decentralized identifiers in the same place. Is this an area you're playing in as well?
Yeah, there's going to be a wallet called Sporan. So Sporan, for those who don't know what the Sporan is, it is the little purse that people wear in front of the kilt. So very close to kilt. It is a bit different than other crypto wallets because a normal crypto wallet just holds coins. It's more like a physical wallet, because when you look at your physical wallet, you will find some coins probably, but you will also find some credentials, like maybe your driver's license, passport or something. And Kilt does exactly that. And I think it's also necessary that software like this is there, because we're always talking like, yeah, and then the user receives the credential. Yeah, what does he do with it? So you need something where you can put your credentials, and you need something where you can also hold your decentralized identifier, and you need something which you can use for signing your credentials with your decentralized identifier so that you can send it out. And this is exactly all what a Sporan does. So a Sporan is a wallet where you can hold your Kilt coins, but where you can also receive your verifiable credentials, where you can send verifiable credentials, sign verifiable credentials, and of course also store verifiable credentials and back up verifiable credentials and everything that you need around that.
Yeah, that makes sense. So then how do you think about the economy or the value flow or value exchange in this model? Because I'm assuming that if people become testers or issuers of credentials, there's some revenue model for them. The fact that it's completely decentralized on a blockchain, where you have both the tokens that could be attached to the DIDs and the verifiable credentials, creates some interesting opportunities for people to amass tokens or amass coins by participating in this economy. What does the whole value flow in this model look like?
Yeah, I think the most important value flow is actually with the attesters, because they do the work in the system, right? There's also the blockchain, and definitely has incentive models for people who run the nodes. But I think this is not the most important part. The most important part in this thing is actually the attester. And the interesting thing about Kilt is that it doesn't facilitate anything about the business model of the attesters. So the attesters are not people which we pick or which the community picks or something. Anyone can be an attester. You can be an attester today if you like. Be an attester. Just make yourself a Kilt account and tell your friends you're an attester. It's not a different role per se. The user and the attester, you can't. The blockchain doesn't make a difference between the two. Attesters. As I said before, the trust is generated in the real world, and the business model of an